Hello, welcome. This is a short introduction to our quantum mechanics book, written by Mingsu from Lanzhou University, China, Tom George from University of Missouri St. Louis, and myself, Guo-ping Zhang from Indiana State University. Please check our webpage for updates. This video is just show you a short introduction. In the next slide, we're going to go over a little more detail. Here I will give you a brief introduction to our book and tell you what our book is all about and what is covered, how many chapters the book has, and what the specific materials. Then I will spend some time to discuss the key features of our book, what differs from other books. We have been using many books over the years. Each time when we use it, we always found something quite too theoretical and sometimes lacks of logics. Very few experiments done by the author himself. In particular, those books mostly cover a single atom. But this is not sufficient for material science today. Then we explain how the instructor and student should use this book, followed by some additional information like sample pages, and we will conclude this particular presentation. Let's get started. In total, there are 10 chapters. We will start with the book with the slower pace and simpler structure. For instance, we did not go into details of blackbody radiation and some additional like a photoelectric Compton experiments and electron diffraction experiments. This is because students often overwhelmed in the beginning by so many experiments in the beginning without going into the true basics in the quantum mechanics. This also takes too much time, too much space. So for the first 3 chapters, these are pretty standard across many books. For instance, Born probability density is introduced with a much easier and simpler method. In this case, a classical airplane, where the direct delta function is introduced. It was so neat, and I strongly encourage you to go through that. The operator are introduced in the following chapters, in particular in chapter 3. This includes Heisenberg uncertainty principles, Schrödinger pictures versus Heisenberg picture. We also do not use spin first approach, because most of the time students have to wait until later chapters to understand wave-particle duality. This is not suitable for a beginner. Chapter 4 is on the hydrogen atom, where the spherical potential, angular momentum, symmetry operations will be introduced. Here we include hydrogen code, computer code. I encourage all of our instructors and the students try them out. Starting from chapter 5, and we will start with the perturbation theory. Chapter 6 introduces these electron spins. So chapter 6 is on electron spins. We provide our own Zeeman effect experiment, ESR experiment, introduced MRI. Introducing ESR is important because it allows us to introduce the Rabi oscillation. This is time dependent. It is mostly merged into the chapter 7, which is time dependent. Chapter 7 is on the dipole selection rules and perturbation treatment, time dependent perturbation treatment. This includes suitability. And this is different from most of these books, other books. And here we introduce the optics smoothly. In the meantime, chapter 7 is most of the time probably maximum number of chapters for one semester course being able to cover. Chapter 8 is on the molecules, and we found it's very important. Similar to the physical chemistry classes, molecules are so important these days. And at the last section of this chapter, we have a one-dimensional Cronich penny model, which is very useful in many cases. And I strongly encourage them, all the readers, to go through them. And we provide a very, very detailed derivation most book does not have. Chapter 9 is Introduction on the Solids. And this is the overall some of these very crucial concepts in solid-state physics. Most of these quantum mechanics book does not have this chapter. So we would like to introduce this way, and we found it's very useful. And lastly, we will talk about many-body systems, magnetism, quantum computing, and preface. And these are very hard topics, and right now it's quite important, so we expand this from many different other books. So what are the key features? Well, let's first start it. First, we have a long table in the beginning of the book. And when we write a book, our goal is that it should be easier to read, both for the students and the instructors. Second, it must build confidence for the students. And especially in the beginning, reinforce what they learned and what they should practice. We also have lots of our own experiments. Here is a list of examples, exercises, and so this way we can engage the students sufficiently. Then each chapter we have longer problems, and so this is the typically at the end of each chapter is more comprehensive. And 318 exercises typically assigned at each section. We have 14 computer codes, which we will show you an example as well. And we plan to upload some videos how to use these computer codes to our webpage. Please check back on this letter. And now we're going to show you what is unique in our book. First, we have a section on the measure the Planck constant experiment, and this is done by our students. And Born probability introduced in a novel way, and we have not seen anyone else use the same method. And we also introduced the Schrödinger equation, use the Noether theorem, which is quite useful in the beginning, including time-dependent Schrödinger equation. Zeeman experiment, we are very proud of the Zeeman experiment, and we introduced a new concept called the Zeeman disk. So here is the diagram in our experiment we used. And then when we introduce spins, we actually have a special way to introduce spin. This is basically extension of the Fermi's very important quantum mechanics book, and we found out it's very useful, accessible to the students. Then we have quantum computing and preface. And the E experiment is also introduced, and it's allowed the students to measure the Rabi oscillations, which is quite useful and important. So next question is that how to use this book. So this slide is basically for the instructors, and so we separate our book into 5 modules. Essentially, for one semester course, first 3 modules should be covered. For 2 semester courses, the 5 modules should be covered completely. Module 1 and Module 2 are absolute basic quantum mechanics, so it must be covered. So this is the Module number 2. And the first exam will be carried out after first 2 modules. And so this essentially, for one semester course, this will be the midterm exam. And then after that, we will introduce Module 3. Module 3 is include Chapter 5 and 6. And this is time-independent, approximate methods, and spin. So this part will be included in the Module 3. So then the second exam will be carried out. And afterward, again, for one semester class, second exam will be the final. So let's move on to Module number 4. Module number 4 is on time-dependent methods and molecules. So these are two things which are so important. For the 2-semester classes, this must be covered. For the 1-semester class, I normally sometimes you could squeeze maybe one chapter there, and sometimes you just let students read them. It's not that hard because most of the core material already covered in prior chapters. It's relatively straightforward, or you can select few sections if you wish. So this is the module number 4. Now let's move on the exams, and this is the third exam for 2 semesters. So this will be the second semester's first exam. So this will be our third exam. And module number 5, which covers chapter 9 and 10. Chapter 9 is on the solid state physics. 9 is on the preface, matter body system, magnetism, quantum information, and these are covered. So, and then followed by the 4th exam. So this will be carried out. In our own experience, we typically assign homework every week, and then every 2 weeks we have one quiz. So then this should be enough. It's not overburdened, but you definitely need assign enough material for students to go through these exercises. Without doing these exercises, it's very difficult to say that students can comprehend these materials. And for the instructors, again, we provide a solution manual. You just ask the publisher if you are interested to adopt our book, either as a textbook or reference. You can just contact the publisher. They will send you a free copy. So you can get a free copy. Additional videos will be posted on my webpage, and you can check back. You are more than welcome to contact us. Here's a web page, and as you can see. Now I'm going to show you what actual book really looks like. So I'm going to steal a few pages from the book and let you to see it. And this is our long table, the first table in the beginning of the book. And you can see chapter 1 and 2. Key concepts are listed here and also followed by formulas. This essentially, if you wish, you can give the students as a select cheat sheet. Of course, after a while, they will remember what these formulas are, what the key concepts are. When we develop this table, and you realize immediately how complicated quantum mechanics is. Remember, the first chapter, you see how many concepts? So it's just very overwhelming. So we want to change this picture. And here is that I promised you to introduce the Bohr statistics and Bohr probability. So in this case, we use airplane. You can see the probability density, rho here of x, is a classical way, and it has a unit 1/meter. So this is our novel way to present. And next few pages after this is essentially introduce the delta function, which is really elegant. Let's move on to measurement of the Planck constant. And for the students, most exciting experiment is measure the Planck constant. These are the IV curve, or current versus voltage curve. This measured by our students, and you can see by measuring the slope, and you can find out the Planck constant. And for the first, I would say for the first chapter, you can impress students such a way that you can actually measure Planck constant. This tells you something which is quite important. Now we also have a way to generate these orbitals, and most of these books did not explain how to actually generate these orbitals. So we actually have small code. Very simple. You can use Excel to do that. We can starting from S orbitals all the way to M orbitals. You probably never seen M orbitals in your lifetime, but here you go. And this particular figure is generated by our hydrogen code. And hydrogen code is free of charge, and it's in the back of the book. When you solve it, you get all these orbitals. You can from 3D, 4D, 5D, you even get F orbitals. I exhausted, and because if you have F orbital, you could have a little more columns. Finally, I want to show you the Courant painting model, so which you can directly solve it and get these band structures, which is also elegant. All right, I think that probably concludes my presentation here. So as I said, writing a book on quantum mechanics is an opportunity to learn quantum mechanics again. By doing so, we learned a lot, in fact. And second, no one can be sure he or she understands it perfectly. So in other words, even after we finish the textbook, we did not realize some of the material we may not understand well. One thing that we really enjoy most is doing experiment ourselves, especially some Zeeman effect and ESR experiment. And I strongly encourage all of the instructors, students should carry out an experiment yourself. If you have interferometers and do the quantum entanglement, in the first chapter we discussed that, it will be really, really wonderful. And just remember, there is always a better quantum mechanics books out there. With this, and I want to thank you so much for your watching, and please enjoy our book, and I would like to see you next time. If you have any questions, just let us know. Bye bye for now.